Hey everybody, Mr. Fritz here. In this set of videos, we're going to go over what function notation is. We're going to add that to the list of what we've already learned so far about functions. And just to recap what a function is. A function is a relation, and not just any relation, it's a relation uh, where every input has only one output. That's important. That's what sets it apart from all other relations. So remember, every function is a relation, but not every relation is a function. It's only a function if every input has only one output. So when we talk about function notation is just that's all it is. It's a notation that shows that we are dealing with a function. So sometimes we see functions written as this instead of this. And really the only difference here that we're seeing is the y and then this funky new symbol here. This funky symbol we would pronounce f of x. And this notation tells us that it's a function, and we name it f of x, and it's dependent on x. So basically it's saying that our function is named f, and we need the independent variable x to be substituted into my function. And so you'll see how this works. It really isn't all that complicated. It's just a new notation. Biggest mistake though is people want to multiply this weird letter f times x. That's not what it means at all. It's just a notation that we would say f of x. F is the name of the function that's commonly used, and x is my input for that function. We could also see functions named g of x. We could see functions named h of x, and really anything a of t, v of t, that's a common one when you talk about velocity and time. This is just how we say these function names. So this is useful when we are in one step trying to evaluate functions for given inputs. So if I were to take this function f and I wanted to find what f of 2 is, basically that's asking me what is the y value when x is equal to 2. So the way that I would find this out is I would find f of 2 by substituting 2 in for x in my function. So all I need to do is plug in a 2 into my x position and evaluate. So f of 2 is going to equal 4 plus 7. And that means that f of 2 equals 11. So what this literally means is that in my function f, if I input a 2, I output an 11. And that's it. I don't need to do anything with this f of 2. I don't need to divide by 2. I'm not trying to isolate f. It's completely different than other letters we've seen in equations before. So this is done. I input 2 into my function f, and I output an 11. And you've done this before. We just have called this y. So what I want you to do is I want you to try f of 5 and f of 0 using the same method here. And I'll put a button somewhere in here to skip ahead. Otherwise, I'll go through these myself, and you're welcome to watch and see how it goes. All right, so for this one here, f of 5, same process. I'm going to plug 5 in for x. So f of 5 will equal 2 times 5 plus 7. Let's keep simplifying here. F of 5 is going to equal 10 plus 7. And finally, that means that f of 5 is equal to 17. When I input 5 into this function machine, out comes a 17. And then finally here, f of 0, we're going to plug in 0 for x and evaluate. So f of 0 equals 0 plus 7, or f of 0 equals 7. All right, so these are the three answers for these three evaluations. And one thing to note here is when we use function notation, it's a given that we're talking about functions. So all of the time that you will see function notation, no matter what the letter, we are dealing with a function. meaning that every input has only one output. So let's see what it looks like now with a different kind of function. It doesn't have to look like this y equals mx plus b form. Here we have a new function. We're going to name this function g of x, and it just has a different rule. The rule means for this function, if you have an x, you're going to square it and then multiply it by 3. So same type of process here. We're going to substitute in our input. In this case, it's 1 for x, and evaluate. So let's find g of 1, and we're going to plug in 1 for x. That's it. Now remember here, I really like when you use parentheses when you're making these substitutions, so be careful with that too. So g of 1 is going to equal 3 times 1, since 1 squared is 1. So g of 1 equals 3. This means in my function g, if I input a 1, out comes a 3. And once again, if you want to see how these work, these the -5, g of -5 and g of -3, feel free to watch, but I'll put a button up somewhere around here to skip ahead to the answers if you're feeling like you know what you're doing here. All right, for this one here, g of -5, I substitute in -5 for x, and I get 3 times -5 squared. If I follow my PEMDAS here, I have to square this -5 first. And a -5 times a -5 is going to give me a positive 25. So g of -5 will equal 75. If I input -5 into my function g, out comes a 75. And finally here, g of -3 is going to equal 3 times -3 squared. Evaluating this, I get 3 times -3 times itself is a positive 9. And so g of -3 equals 27. So that's how you would evaluate a function for a given input. We stick in an input and out comes an output. And the way I like to think of this is kind of like a machine. So if I were to draw kind of a crude looking machine here, this machine has things going into it, and then something happens. Let's draw a little gear here. Something happens in this machine. It makes all kinds of noises and whirs around, and something happens, then out comes an output. And let's call this machine F. That's what I want to name this machine. And if we look back at all these situations here, all these different examples, if we plug in a 2 in our machine, F, it's going to do something inside, it's going to follow a certain rule, and out comes an 11. If I were to take this same machine and I were to input a 5 in here, it's going to do something, it's going to follow a certain rule, and out comes a 17. And finally, if I were to input a 0 into this machine called F, what we've just found is that it's going to do something inside this machine, and out will come a 7. So that's what I want you to start to get in your heads about what a function is and what function notation is. It's all about inputs and outputs. And the way that we get these outputs is by following a certain rule of this machine given by what our equation is. The rule for f of x is take your input, multiply it by 3, and add 7. So in the next video, we're going to take a look at working backwards, and we'll see how that goes.